Natalie Kools is trying to do that, not for agriculture, but in the domain of forest management too. And I propose to listen to Natalie, and then to also to listen from Ukraine. This also, we know that we have in this moment a great social problem going on, and then open a debate, open a discussion. Do you agree?
I think a social problem, you say it's the social problem.
Social.
I don't think it's so much a social problem. I think it's a marketing problem. The agricultural chemical companies and the oil industry have an enormous, if you work out at a few percent per unit, what they sell, they've got something like $1 billion a week to convince the world that it's not something that can be fixed quickly. It can be looked after. If we had that sort of money to spend convincing people, we would change the nature of the social problem, because it's the social problem that we have acquired as we've grown up. I remember years ago, I was thinking of ammonia as a possible fuel for vehicles and things like that. And I knew in my head, I had already been conditioned. I knew it wouldn't work. And it's just starting now to become acceptable. Not acceptable. Big people are starting to use it. They can see the money involved. But I didn't write about it in my book because I thought it just wouldn't work. So I was personally conditioned to dismiss what really was a very, very good idea. And the production of wave energy and the production of was wave energy and tidal energy. There's a lot of talk about this. The reason that that is talked about, because they know damn well it won't work. If you do the sums, you need about 0.5 meter or 1 meter of a wave to generate enough power for one person. That would mean for a couple of million people, you need 1 million meters, 1,000 kilometers or so to produce enough power for 1 million or so people. So it's just tidal energy, and you work it out like that, and it's frightening. Suddenly you realize it, but it's being promoted. It's being promoted because it is a failure. It doesn't affect them. So I know it's a social problem, but I think the social problem has been deliberately created.
Okay. Thank you, Alan. I'll let the public to Natalie.
Thank you, Augusto, and thank you, Alan and Lucas, for already very interesting contribution. So I will take you to the European forest soils. So I go to the natural systems where we expect people did not yet or did not influence too much the organic carbon in the soil. And maybe I will, so maybe I have to situate my work first. So I'm Natalie Kools from the Research Institute for Nature and Forests in Belgium. And I'm active within the ICP forest program, where together with my colleague Bruno de Vos, we focus on the soil characterization and the changes we see in the European forest soils. And our work frames in the ICP forest program, and that's an international cooperative program that started in the 80s already, to study the effects of air pollution on the forests. So it started with the acid, studying the effects of acid rain on the forest. So this was mainly due to the sulfur deposition. This problem in the meantime has has been solved, but the problem that our European forests cope with during most recent years is more it's a bit similar to what you see in the Great Barrier Reef. So it's the nitrogen deposition, which is really affecting our forests all over Europe. I'm gonna share my screen.
Okay.
You can see it? Okay. I approached the humus research group more than 15 years ago in San Vito in 2005, because it was just before a moment in time that within the ICP Forest program, we wanted to start up a new soil inventory across Europe on about 5,000 locations. And we wanted to have a good classification key, a very rough level, that the foresters would use to classify their humus forms. So at that time, the group was still at this beginning of this very good classification key of humus forms. But at that time, so you see here on the picture, one of these first keys that we used. And also at that time, we started the traditional humus forms that we distinguished in Europe in forests were mul, moder, moor for the upland soils. And when we look at the water saturated soils, and so we had peat, and within peat we distinguished a comparable system of mul, moder, moors, but then in dehistic forms. So this was a bit what, and then we had a lot of more subdivisions, but this was in fact the starting point of humus systems that and key that we took in the field to classify our humus forms. Important or interesting to notice that is that so within ICP Forest we work on two monitoring levels. So at level 1 we have now currently more than 5,600 plots. They are systematically spread across Europe. So we use a grid of 16 kilometers, and at each point where there is a forest on this grid, and there ICP Forest level 1 plot is installed. And the aim of this systematic grid is to gain insights in the geographical and temporal variations in forest condition. So the main objective is looking at the condition of the trees and the vitality of the trees. But on this level 1, we also take into account a number of soil parameters. And then on the level 2 monitoring level, there ICP Forest goes much more into detail. That's an intensive monitoring program, also been set up already beginning of the 90s, but there we do a much more chemical analysis, and we try to clarify more cause-effect relationships. Many of these sites of level 2 are also included in the long-term ecosystem research network that we also established in Europe. And in Australia, I know there's also an ELTER network with this type of intensive monitoring sites. When looking at the humus, in the beginning of the program, the classification of humus was part of the crown condition monitoring program. So between 1987 and 2011, it were the foresters who assessed the condition of the trees that also looked at the humus and described the humus form. But as already told you, we were in 2005 just before a second soil inventory. So most of the samples of the second inventory were taken in 2006 and 2007. And there we introduced the key that the humus research and the group developed at that time at a very general level. And we included it in our manual. So we classified the soils and the humus forms, and we also took samples of the organic layer. So we distinguished the LOL layer. We made one sample of the OF layer in most plots, but in sites where the humus layer, so the OH layer, was thicker than 1 centimeter, samples were taken separately. We analyzed peat layers and also the mineral soil according to fixed depths. Samples were collected of nearly 5,000 plots across Europe. But then the ICP Forest is a long-term monitoring program, and of course now we are again so many years further, and we want to know, do we see any changes? And so this is just a graph of the classification. So we had our major humus systems. So the program was initiated in '87, and so the increase of the different number of plots and the humus forms we find on these plots is just due because more and more countries joined the program. And then after 2007, then you see that the total amount of plots also decreased because more and more countries at that point, they did not monitor that intensive anymore on the same sites. So you see that, so this is still 2011, but during the years, some countries joined the program and other countries left the program. So it's difficult to see at this level any changes over time. Then, but here I just compared the situation when we made our first soil inventory in about mid-1990s, and then we made a second soil inventory in so the period 2006-2007, and then it seems that maybe there was a change in our main humus forms, but this was done on the whole set of plots. But as I already said, with composition changed a bit, so it's difficult to compare. Yeah, this is just the example of the countries and number of plots that were involved in the first soil inventory, and these were the countries involved in the second soil inventory. But when we look at the common plots, so the plots that we were visited in 1996 and were visited in the second inventory, so between 2006 and 2008, we see that in the upland humus forms, there was not a big change. And when we look at the more moisture saturated humus forms, yeah, this is also very difficult to get a good picture because in the meantime, we applied new definitions, and so changes can be due rather to the type of system that was used. So at this level, there's no, I don't think we will see a lot of changes over time. So within ICP Forest, we focus much more on the chemical analysis that we do on the samples. And this is a map that was the result, in fact, of our forest inventory between 2006 and 2008, where we classified all the humus forms according to the European key at the at the highest level we had at that moment. So we distinguished mulmoder and more humus forms. We had the amphi included. Tangle was in fact there, but it was not recorded in our sites. And then we had unmoor and the water saturated, so more the peat soils. We distinguished a histomul, histomore, and amphi. So these forms are not used anymore. So in the meantime, the system changed, and the names of these humus forms changed. But I think in this map you see a bit, yeah, the European distribution that we have of the different humus forms. And on all of these, or most of these sites, we also have chemical data of the forest floor. And when we, again, yeah, I just show you these numbers, but you can find these numbers in a paper of a colleague of me, of Bruno de Vos, where we, for each of the humus layers that we sampled, the countries and measured the carbon content, and we also have an idea on the mass organic layer, on the bulk density. And so we came to estimates of the carbon density. So this is the amount of carbon that is contained in 1 centimeter of forest floor soil. And then we see that carbon densities are different between our different organic forest layers. That's in the aerated forest layers, and so the O layer, the density is lower than in the wet forest soil layers. We also looked at the carbon content in the, according to the major humus forms. So we had data on more than 4,000 plots, and we calculated the mean carbon stock that is contained in these humus types. So when we look at the traditional mulmoder moor upland soils, you see a nice, beautiful increase in the carbon stocks. So it's really these are means for all European forests. Then the amphimule is in the range between of moder and moor, so in between. Then the unmoor, so the humus form, which is between the aerated and the water saturated, is also in a similar range. And then when you look more at the humus forms of peat soils, you see a very large increase when we go to the thicker peat soils with where the humus is not that well decomposed, and so we get very high carbon stocks. That we also analyzed the nitrogen content in these layers, which allowed us then to calculate the CN ratios. And CN ratios are very often used as indication also for leaching of too much nitrogen from the soil. So it has a high impact on the, for example, groundwater quality. And also there we studied the CN ratios of the the aerated and water saturated forest floor layers. And there, so we came to, and so the organic layers which are less decomposed have higher CN ratios than the real humus layer. But also in the we also have the CN ratios in the peat topsoils, and so we could establish some of these, we call them benchmark values, but in general, it's not that much. It is mainly the 3 species type we concluded that influences, in fact, these the values of the CN in the forest floor. Also by humus type, we looked at the CN and ratios, and there we get in the differences are maybe not that big, but we see here that in the histo forms they are somewhat lower. In the more humus type, we get the highest CN ratios. This is compared, so this is in the forest floor on the left, and on the right we get the values in the mineral top soil, which is clearly much less than in the forest floor. Then maybe one more addition is to talk about our level 2 intensive monitoring sites, where we go more into detail on the soil characteristics and on the characteristics of the whole ecosystem. So in this survey, you see the distribution of the humus forms that we have on these intensive level 2 monitoring sites. But the first survey was conducted in the 90s. But you see that the number of plots that we had in our second surveys is much less. And this is because these data, it's not that they do not exist, but they never reached our central database. So I looked here at the plots that we have in common in our first and second inventory, but these data only come from 6 countries. So I really hope in the coming years that from countries that still have data of after 2000, that they also would submit this data to our ICP Forest database, and that we are planning to write a book in the coming year on our conclusions that we can draw from all the data we have at present in ICP Forest database. But you see that the Italian data is also still missing, and I know that a lot of surveys were done in Italy after that date, so that we are also still waiting for the Italian data, but I'm sure they will come. And then so I hope that in the coming years we can have more data on our level 2 plots. Also, a lot of countries started with a third systematic soil survey on this 16 kilometer grid. But unlike previous times, there's not any money coming from the European Commission, so all the countries have to pay it themselves. So we will not have a very good coverage, I think. But we are trying to stimulate the countries to really analyze their soil again, and within our program. So I think I can more or less stop my talk here, and thank you for your attention.
Thank you, Nathalie. Oh, what a beautiful...
It's an artwork of my daughter using material that she found in the forest. So it's an appropriate picture.
Yes, I see that the core is made by coniferous needles, and you have all around different species.
Yeah, like cones of the pine trees and needles and leaves and twigs. Yes.
Okay. That will Lucas, what do you think of this?
I will tell her.
Very good, very good. Excellent.
So I before starting with discussion, I will let the floor to Elina from Ukraine. and